Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the diesel cycle and its optimization. The diesel cycle is the ideal cycle for compression-ignition reciprocating engines. The CI engine, first proposed by Rudolf Diesel in the 1890s, is very similar to the spark ignition engine discussed in the last section, differing mainly in the method of initiating combustion. In SI engines, the air-fuel mixture is compressed to a temperature that is below the auto-ignition temperature of the fuel, and the combustion process is initiated by firing a spark plug. In CI engines, the air is compressed to a temperature that is above the auto-ignition temperature of the fuel, and combustion starts on contact and the fuel is injected into this hot air. Therefore, the spark plug is replaced by a fuel injector in diesel engines. The diesel cycle is a particular case of dual cycle when the pressure ratio is equal to 1. Therefore, the diesel cycle can be analyzed following the procedure for dual cycle with unity pressure ratio. This means the isochaloric heat addition disappeared and the state A merges with the state 2. From equation 10.7, the thermal efficiency with the setting of pressure ratio of unity then is. It is found that the efficiency depends on the compression ratio and the cutoff ratio, and the limitation is the Carnot cycle efficiency between T1 and T3. Again, when all the obstacles are overcome, the thermal efficiency of the diesel cycle can be very close to the limitation of Carnot efficiency, and the net work output per cycle will be quite close to 0. Therefore, there should be a compromise between the thermal efficiency and the net work output. With net work output per cycle, a larger mass flow rate is needed to maintain the same expected power output, which may not be economical, especially for the vehicles. Firstly, let's talk about the optimal compression ratio. There must exist maximum error between the fixed temperatures of T1 and T3. The compression ratio in this case is called the optimal compression ratio. Following the process for the analysis of dual cycle, we can obtain optimum operation properties. The cyclic specific network is. The optimization can be done directly from that of the dual cycle with the unity pressure ratio. Secondly, with the optimal compression ratio, the dimensionless maximum cyclic specific network can be expressed as. It is found the dimensionless maximum cyclic specific network depends also only on the ratio of T3 and T1. Thirdly, the optimum thermal efficiency can be expressed as the optimal thermal efficiency is found depends only on the ratio of T3 and T1. Fourthly, with the optimum properties, the optimum mean effective pressure is determined as, with the cold air standard assumptions, the MEP with the optimal expression ratio of diesel cycle is also determined by the temperature ratio of T3 and T1. Again, I have questions for you. Can you try to find the compression ratio for the maximum MEP? Is it the same as that for the maximum cyclic specific network? Okay, that's all for this task. Thank you very much and see you next time.